This video is going to talk about how to approximate square roots, just to get an idea of what the value would be when you don't have a calculator and are not able to fully see exactly what it would be. So to start off, we're going to look at some patterns with the square roots between 2 and 9, which we've seen a little bit in class, so we should be kind of getting familiar with them. If you look, the only two that are perfect whole number answers are 9 and 4. And we've talked about how 9 and 4 are perfect squares. So what I want you to look at is the numbers in between 4 and 9. So if we're looking at 5, 6, 7, and 8, what do we notice about the square roots? Well, the square root of 4 is 2. The square root of 9 is the next whole number, which is 3. And if you notice, all of the numbers in between 4 and 9 have square roots that are in between their square roots. So the square root of 4 is 2, the square root of 9 is 3, the square root of 5, 6, 7, and 8 are all in between 2 and 3 as well. So what we can do is start using the perfect squares as almost like benchmarks of how to compare other numbers to them to see what their values would be. So let's look at an example of on a number line between which two consecutive integers would the square root of 70 be located. We're seeing some familiar vocab here with the word integers, which remember is positive and negative whole numbers. So between what two whole numbers, positive or negative, would the square root of 70 be? So what you want to be thinking is you want to be comparing the number to the closest perfect squares, because remember that's kind of what we're using as our benchmarks. And that means that the square root of those would give me the range of my answers. So I want to think 70, what are the two closest perfect squares? The first one that came to my mind is 81. So 70 is less than 81, but it's decently close. And then the other one on the other side would be 64. So 64 and 81 are my two closest perfect squares to 70. So what that means is the square root of 70 would be in between the square roots of 64 and 81. Since we're using perfect squares, we know that those would be whole numbers, so the square root of 64 would be 8. Square root of 81 would be 9. So what we're saying is that the square root of 70, we would guess would be between 8 and 9. If you want to check it on a calculator, you would see that the answer is actually 8.366. So we got pretty close, between 8 and 9. Let's look at two more examples just so we can keep working on this. It says approximate the square root of 47 and the square root of 28 by evaluating what perfect squares they are closest to. So let's start with the square root of 47. The first thing I want to do is be thinking about what perfect squares are close to 47. We have one that's very close, which is 49. And then on the other end, it would be 36. So remember, what I'm really saying is that the square root of 47 would be in between the square root of 49 and the square root of 36. Well, the square root of 36 is 6. The square root of 49 is 7. So I would guess that the square root of 47 is somewhere in between 6 and 7. We can actually start to get more specific than this. Since 47 is closest to 49 than it is to 36, we would guess that that square root of 47 would be closer to 7 than 6. So maybe something like 6.5 or above, if we wanted to be more specific, but we don't have to. Next example is the square root of 28. Same thing. What perfect squares are closest to 28? Well, 36 is actually still going to be in this example. And then on the other end of that, we have 25. So what I'm saying is that the square root of 28 is going to be in between the square root of 36 and the square root of 25. For my final answer, I would say that the square root of 28 is in between 5 and 6. You can also use this strategy if you're trying to plot square roots on a number line and just want a general idea of where they would be. So if I'm looking at the square root of 6, I would want to think, well, those are going to fall between what two numbers using the perfect squares that they are closest to. 6 is closest to 4 and 9, so its square root would be in between the square roots of 4 and 9, which are 2 and 3. So the square root of 6 is going to go somewhere in between 2 and 3. For the square root of 12, that's in between 9 and 16. So my square root of 12 would fall in between the square root of 9 and the square root of 16, which would be in between 3 and 4. So that would go somewhere here. And then the last example, the square root of 50, that's closest to 49 and 64. So the square root of 50 would be in between the square root of 49 and the square root of 64, which is 7 and 8. Definitely closer to 7 though, since 50 is so close to 49. So if I wanted to get fancy, I could put it closer to 7 rather than somewhere in the middle. The last example is going to be one that we're actually working backwards. It says the square root of an integer n is between 9 and 10. What is the range of possible values for n? So this time what it's saying is we already have the square root of n, and we know that it's in between 9 and 10. What it's asking us to find is what would n be in between, not the square root of n. So what we can think of is, how can I go the opposite way? These are already what the square roots would be, so I want to do the opposite of square rooting something. If I square these numbers, what that would give me is 81 and 100. Squaring and square rooting are inverse operations, so those are going to cancel each other out in the middle here and give me n. So I'm saying n would be somewhere in between 81 and 100 in order for its square root to be in between 9 and 10. We'll talk more about this next class, but hopefully this was a nice kind of preview for you for approximating square roots.